Circle graphs, they're also known as, aka, pie graphs and or pie charts would be the same thing. Okay. And when do we use circle graphs? Why not use a bar graph? Why not use a broken line graph? When do we use the circle graphs there? Alex? Yeah, for percentages, usually when you are splitting up one whole thing. Okay? When you're splitting up whole things. Splitting up whole things. And when you want to know what fraction or what percent or what part, what part of your day, for example, here's my pie graph here, just throwing down some stuff here. This pie graph is going to stand for a 24-hour day. It's a whole day. If you sleep from, I don't know, 10 o'clock at night till 6 o'clock in the morning, I don't know what you do there. 10 o'clock at night till 6 o'clock in the morning, that is 8 hours sleeping. Okay, and then you go to school from, 8 o'clock to 3 o'clock? Well, how many hours is that? 7 hours. So then you got another 7 hours sleeping. That gives me 15. I still have 9 hours. Maybe you play 2 hours of sports. And then, I don't know, you watch TV or let's just say entertainment. What are we at here? 15, 16, 17 hours. You probably do 5 hours of entertainment. Maybe that's not true for you, but. And I believe we're left with, 15, 22 hours that maybe you spend, whatever, eating, doing, let's just call it personal time, because there's all sorts of stuff, driving to school, okay? I'm splitting up a whole day, and a circle pie graph helps you visually see, what you do the most of. I mean, right away, without really looking at the numbers there, you can tell that you spend more time sleeping and going to school than you probably do anything else. Taylor, question?
Well, why are there two different parts of sleeping? You put sleeping for school.
Oh, that probably was supposed to be school.
Yeah.
School!
Oh.
We
So
do
you
sleep in
sleep.
school, so.
Yeah,
We
most
do
of
sleep in
most
school.
of you spend most of your time sleeping at school anyway, so it's about the same thing. Okay.
Sorry.
So there again, your circle graph, your pie graph just splits up that whole day into different parts. But there's questions that they're going to ask, like this: what fraction of the day do you spend sleeping? In which case you're going to have to do a little bit of work, because you know that you spend 8 hours sleeping, okay, but you need to figure out what the bottom number is, and the bottom number would be how many total hours during the day. Unfortunately for here, I gave it to you. But if the pie graph or the bar chart or the pie chart didn't give it to you, you'd have to sit down and add up all the different pieces and see what they total. You spent 8 out of 24 hours sleeping, which reduces down to what? Pretty much 1/3. And you probably should be spending that much of your day sleeping, if not more. Some of you probably do spend more. What fraction of your time is sports?
24.
Right. 2 hours out of the 24, which is about 1/12 of your day. You could make your own little chart there. I'm sure you'd come up with something over there. Or here's another question they ask. Gosh, this would be tough. I gotta find a good one here too. What percent of your day is spent? Sure, let's go sports. Unfortunately with this, we know sports is a fraction 1/12. Any idea how I can figure out what percent 1/12 is? That's not an easy one to do. And the book won't ask you that, so if you don't catch this, you don't. Give me a guesstimate. 1/12 would be close to what percent? Remember, percent means out of 100. So 1/12 is what percent, or what part of 100? If you took, Alex says about what?
10%?
10% is close. Did you say 7? Or 7, we're close. Sam?
20%?
Oh no, not even close to 20. And again, here's a way to think about it. You want to know what? 1/12 is what percent of is what part of 100? Is what percent? So here's your little box. This box stands for 100%. And what are you doing? You're cutting it into 12 equal pieces. So if you take 100 and cut it into 12 equal pieces, what do you suppose you're going to get? If I take 100%, which is all of it, cut it into 12 equal pieces, 12 goes into 100 8 times, which is 96. Subtract, I get 4, 8 and 4/12, which is actually 8 and 1/3. 8 and 1/3% is what it would be. They won't ask you that. I just threw that in there because it happened to me. I just made up this chart. They'll give you ones that are easier than that. As a matter of fact, let's look at one here. Insert file. Where are we going from?
40.
40. Math stuff. Science and stuff. You guys, your course one. You said it's 40, right? Let's look at one that they give us here. Hopefully it won't take long to magically appear.
2.
Don't worry, it's here somewhere. Take a look at this one here. It says Brecht collected information from his classmates about their pets. He displayed the information and the number of pets in a circle graph. The first question they ask you is, how many pets are represented in the graph? How many pets are represented in the graph? Now they don't want to know how many different types of pets, they want to know how many total pets there are. So you'd have to add up the 16 plus the 8 plus the 4 plus the 4. They don't want to just know that there's 5 or 4 pets there, 4 different types. They want to know how many total pets. Alex?
32.
32. So there are 32 total pets there. That's going to help you with the rest of your problem there. What fraction of the pets are birds? How many birds of those 32 are there? You can see that far it's 4, which reduces down to 8 goes into both of those. And then the question they ask you is what percent are dogs? Well, dogs are the fraction 16 over 32, which is half, and half is what percent?
50.
50%. So 50% of them would be dogs.